But chemistry is going to be a little bit longer, a little bit more difficult. So you'll want to watch the video posted Monday because we talked about isotopes and mass number calculations that day. And today what we're going to do is we're going to look at the equation sheet that I handed out, the chemistry equation sheet, and we're going to learn how to use these equations. So we're going to be talking about molar mass, moles, and Avogadro's number. So we're going to relate those terms to each other and then look at some example problems on which we'll be using those. So let's start by looking at molar mass. So when we're calculating molar mass, what you need is a chemical equation, or I should say chemical formula. And from that chemical formula, what you're going to do is you're going to take the number of atoms of each element present in that chemical formula, and you're going to multiply it by the average atomic mass on your periodic table. So it's easiest to explain this concept by just showing an example of it. So if you're asked to calculate the molar mass of something, you'll be given a chemical formula and you're going to apply this equation here to it. So what's an example of a formula? Let's do this guy here. So this is a chemical formula. It's got elements from the periodic table and it's got subscripts after each element. So it's going to take some getting used to if you've never really taken chemistry or looked at the periodic table to recognize what these elements are. So Cu, you could find that using your periodic table. It's copper. It's number 29. You want to follow along and look for it. You can see the chemical symbol Cu, so that's copper. Why do I need to find it on the periodic table? Because that's where I'm going to get the average atomic mass. Okay? So the easiest way to approach these is to make a list of all the elements you have in the formula given to you. So we just said copper is one of them. Next we have an S, that's sulfur. Next we have an O, and that's oxygen. And then based off of this list, to figure out the number of atoms of each of these elements, you're looking at the formula itself. So the subscripts, the numbers that come after each element, that tells you how many atoms there are of each of those. So for instance, copper, it doesn't have a subscript. But that just means there's only one atom of copper in this compound. So I'm going to make a list of the number of atoms of each. So one copper. For sulfur, there's just one of those as well. Now moving on to oxygen, there's a 4 after it. So that's saying there are 4 atoms of oxygen. So we get the number of atoms from the chemical formula using those subscripts. The periodic table part is to find the average atomic mass. So when I look up copper on the periodic table, we just looked it up a second ago, it was number 29. What I get on the periodic table is the symbol. There's a 29 up here, and then there's a 63.55. This 29, this is the atomic number, which is the number of protons. We talked about protons in the last class. Protons are positively charged subatomic particles.
If I change the number of protons, do I change the element?
Yes.
Okay.
So you just had an interruption from someone, but if you change the number of protons, I was about to say that next, you change the identity of the element itself. So the number of protons actually stays the same for all copper atoms. That number won't change. This is the number we want to look at when we calculate molar mass, though, because this number is our average atomic mass. This guy here. We're going to look up each of these elements, and in this column here, we'll write the average atomic mass of each. So copper, we just said was 63.55. Then you'll look up sulfur on the periodic table, it's number 16. So that's 32.07, its atomic mass according to the periodic table. And then oxygen is number 8. And 16 is going to be its average atomic mass. So to figure out the total molar mass, remember that's what we're trying to calculate, we multiply across atoms times the average atomic mass. That's 64, either 16. I got that wrong. 4 times 16. That's not 64, that's 48. No, I don't know. Need my calculator. They actually had it right. So once you multiply across, then you're going to add all these values together to get the total of that compound as a whole, total molar mass. Okay, so 159.62. Now for units on this, they are grams per mole. Grams because it's a mass and we can measure mass in grams, kilograms, etc. And then the per mole is because it's a molar mass. And we're going to talk about what a mole is next. So that will help explain that a little bit better. All right, so what we're going to do now is look at a few of these equations on your equation sheet. So we have moles is equal to mass over molar mass. So what we just looked at is calculating molar mass. So if you ever use this equation, you'll be given the mass of whatever chemical compound substance, and then you're going to need to calculate the molar mass doing this, and then plug that into this equation. Okay, so that's how we're going to see that one used. We'll do some examples here in a moment. Now this next equation is the same thing, just rearranged. Okay, so in this case you would be solving for mass. The question would give you the moles and a chemical formula so that you can calculate the molar mass, just like we did over there. So we haven't yet talked about what a mole is. So we know what mass is already. We just talked about what a molar mass is, but what is a mole? And this is where the next line comes in. A mole is a way of measuring the amount of a substance. It's actually the SI unit for measuring the amount of a substance. We looked at a mole in chapter 1 briefly in a table, but we didn't really talk about its definition. And the mole is defined by Avogadro's number. So this very, very large number, 6.022 times 10 to the 23rd, that's Avogadro's number. Now, what this number tells us is it's going to tell us either how many atoms, or how many molecules, or how many formula units are in a particular substance. So if I'm talking about, let's say oxygen, okay, and I say I have 1 mole of oxygen. Remember, a mole is an amount of a substance. So if I say I have 1 mole of oxygen, what this is saying is that in that 1 mole that I have, there are 6.022 times 10 to the 23rd atoms present. Now, atoms are extremely tiny, very, very small. And this is a huge number, but that makes sense because if you have a tangible amount that you can actually hold of an element, it's going to have billions upon trillions of atoms in there. Okay, so this is how we're defining it. This allows us to count how many atoms are in a given substance without physically counting them one by one, because that would practically be impossible. So that's how we're going to be defining a mole, and we're going to use this number in some calculations, and that's what the next 2 equations on your equation sheet are. They are converting between atoms or entities and moles. So I'm not going to write those ones down because you'll have them available to you. Actually, I might as well, because if we're going to do a problem, then I can refer to it a little bit easier. So number of entities or particles, moles times. And the rearranged version, dividing. All right, so let's look at some problems that you might encounter on the homework quiz or an exam, and how you would apply those following equations. So the first problem we're going to look at is how many moles of C3H8O are in 42.1 grams gram sample. Just say sample. Make it easy. Okay. So remember, we're going to be applying one of those calculations. So it's kind of like physics. I mean, it's a word problem. Let's look at what they're asking us to solve for, what information they gave us, and then pick an equation that works. So how many moles? So this is the question mark. We're solving for moles. So that narrows down our equations already, because whatever we're solving for, we want to pick an equation where moles is equal to. So it's either going to be this top one or this very bottom one. So to figure out which one, look at what they gave us. What piece of information? What's our known? Well, they gave us the chemical formula, but they also gave us 42.1 G, and that's grams. And grams is a mass. Okay, so we're looking to solve for moles. They gave us a mass. We narrowed it down to these two equations. This equation down here is to solve for entities, atoms, molecules. No, they didn't give us atoms, they didn't give us molecules, but they did give us mass. So we're going to be using this top equation to solve. Now if we use that top equation, you'll see, I switched screens now, that we need molar mass. That's what's in the denominator. So they did give us our 42.1 grams, that's our mass, but to solve for moles, we also need the molar mass. So we're going to be using the chemical formula to figure that out. Because remember, for molar mass, we're going to use the chemical formula to figure out the number of atoms of each element in that compound, and we're going to multiply it by the average atomic mass on the periodic table. So I'm going to go ahead, this is my molar mass calculation, that's what MN means, molar mass, and make a list of all the elements in that compound. So I have C, H, and O. Carbon, hydrogen, oxygen. For the number of atoms of each, look at the subscripts. So how many carbons are there? 3. Just 3, yeah, we're just looking at the subscript there. Hydrogen, 8, and then oxygen, 1. Just 1. If there is no number after it, you assume it's 1. Next, we go to the periodic table, and we find carbon on the periodic table and write down its mass. Remember, that's the decimal point number underneath the chemical symbol. So carbon is 12.01. Hydrogen, it's the very first element on the periodic table, 1.008. And then oxygen, we actually looked that up in our last molar mass calculation, it was 16. So what we're going to do, multiply across, and then we add all of these numbers together. So I already did this calculation. Didn't have to waste time using my calculator here. But I get 60.09 once I multiply all of those across and add them. So this is the total molar mass, this guy here, of that compound. So now we have our molar mass and we have our mass. So we're just going to plug those numbers into this equation to solve for moles. So the mass from the problem itself is 42.1. The molar mass we calculated using the equation of 60.09. And notice the units. Grams are canceling. And that's good because what we're solving for is moles. And moles are the only units that are going to be left. So when we divide those, we get 0.701. Why did I go out that far? Because I used the significant figures of the number in the question. There was 3 significant figures here, so I kept it at 3 there as well. Try another one? So let's look at calculating molecules this time. So the next question is calculating molecules. How many molecules of CO2 present So, figure out what equation we're using, look at what they're asking us to solve for, and what information they gave us. This time, how many molecules? So that's the question mark, is the molecules. Whenever you see the word atoms, molecules, or formula units, you are going to be using Avogadro's number somewhere. Because that's what the entity stands for. It's to solve for atoms, molecules, or formula units. So I've narrowed it down to these bottom 2 equations here. Okay. What they gave us was 0.166 moles. So they're asking, in this sample that they have of carbon dioxide, how many molecules are present in that sample? So to solve for this, we could use either of these equations, but I'm going to pick the top one because that way I don't have to rearrange it myself. So number of entities is going to become number of molecules. So I'm going to say molecules is equal to, and then it's moles times Avogadro's number. 6.022 times 10 to the 23rd. So practice again with using superscripts. Powers up with your calculator. So I'm going to plug in my molar amount in that mole spot. So it's just 0.166 times 6.022 times 10 to the 23rd. So these ones are nice because you don't have that side calculation of calculating the molar mass. So when I plug that in, I get 10, well I had to round it up to get 3 sig figs. 10 times 10 to the 22nd. So that's how many molecules are in that sample. So next we're going to look at how many atoms needed to make So this one we're calculating atoms. So once again, we're using Avogadro's number. You see atoms, molecules, or formula units, it's one of those 2. What they gave us was the amount of moles. So we're still using the same equation we did last time, it's just instead of writing molecules where entities is, we're going to write atoms. And the reason that atoms are being used right now is because we're talking about an element by itself. So whenever you have just one singular element, it's made up of atoms. In the last problem with carbon dioxide, we looked at CO2, and the word that was used was molecules. That's because this was a compound. These are 2 elements combined. Okay, so they use the word molecules instead of atoms in that case. Just in case you're wondering why the different terms. All right, so these ones are pretty straightforward. You take the molar amount, plug it in and multiply it by Avogadro's number. So it's 5 times 6.022 times 10 to the 23rd this time. So answer to two significant figures, 10 to the 24th atoms. So that's how many atoms you would need to make up a 5 mole sample of silver. And we could take that 5 moles and figure out the mass of the silver too, using this equation. So you can know how much you need to weigh to get that many atoms. So there's, chemists use these calculations on a daily basis. Now we're going to try one a little bit harder. So how many molecules iron sulfate 122 grams. And for ones like this, I'll usually give you a hint. So the reason for the hint is because this is just a two-step problem. Because they're giving you, let's look, over here, grams, a mass, and they want you to solve for molecules. Well, I said if you're trying to solve for molecules, it's going to be one of these two equations down here. But notice, in order to solve for molecules, you need the molar amount. They didn't give us the molar amount. They gave us the mass, the gram amount. So there's a middle step, and the middle step is to calculate the moles. Okay, so the plan is to take that grams, that mass, and go to moles first. And then use a second equation to go from moles to molecules. So let's look at this first step, because the mass is what they gave us. So if they gave us the mass and we want to go to moles, we're looking at one of these two equations. In this case, moles is what we're trying to get, so we're going to pick the top one. That way we can plug the mass in up here and then divide by the molar mass. So in order to do that, I need the molar mass. How do I get the molar mass? They gave us the chemical formula. We use the chemical formula. We make that list of all the elements present in the chemical formula, write the number of atoms of each, and their masses from the periodic table. So I have iron, sulfur, oxygen. So this is molar mass calculation of iron to sulfate. The number of atoms of each, we're looking at the subscripts. So iron, 1, sulfur, 1, oxygen, 4. Then we multiply by the molar masses, or the average atomic mass on the periodic table. So for iron, we look up iron on the periodic table, and I don't know what that one is. It's number 26, but its mass is 55.85. Sulfur, I looked that up a minute ago, 32.07, and oxygen is 16. So these numbers were all finding the chemical symbol on the periodic table and coming up with the mass. So multiply across and then add all of these values together. I get 151.92, And remember the units on it are grams per mole, because this is the molar mass that we're going to plug in here. And the units, we need the grams to cancel and the moles to stay. So 151.92 grams per mole. So this is going to get us to the moles, so that next we can go to molecules. So when we divide this out, it tells us that in that 122 gram sample, we have 0.803 moles. So now we're going to go from moles to molecules. So moles to molecules, we're moving down to these equations. Molecules is what we're solving for, so I'm going to pick the top one so I don't have to rearrange it. So I'm going to say molecules instead of entities. Just replacing the word molecules in for number of entities. Then we're going to take the mole amount that we just calculated and multiply it by Avogadro's number. So taking this guy, plugging it in there. So 0.803 times 6.022 times 10 to the 23rd. Answer here. So what that tells me is that this mass of 122, if I had 122 grams of iron 2 sulfate, there would be this many molecules in it, right? Trillions, probably even more than trillions. What's bigger than trillions? Is gazillion an actual term? I don't know. I know it's more than trillions. It's a lot, but all right. I have one more left to do. And then next week we'll be taking these formulas and naming them, being able to come up with the names. We'll talk about ionic and covalent compounds next week. So we have 0.039 moles of salt. Calculate. So this is kind of a pared down version of a longer question. So the American Heart Association recommends that you should only have 0.039 moles of salt, table salt, sodium chloride per day. So what we're going to do is we're going to take this molar amount and we're going to calculate how many grams that is. Because obviously when we're eating salt on a daily basis, we're not looking at the molar amounts we're eating. We're looking at the mass amounts, the gram amounts, milligrams, grams, so on and so forth. So for this one, they're giving us moles and we're trying to go to grams. Okay, so we don't see atoms, molecules, formula units anywhere in here, so we can get rid of or know that we're not going to be using Avogadro's number. So don't look down here. So we're looking up here. Now this time, we are given the moles and we're asking to solve for mass. So I'm going to pick the second equation this time. That way I don't have to rearrange it, because mass is what I'm trying to solve for. The mole amount I can plug in here, and then I need to come up with the molar mass to multiply those two. So, using this equation, mass equals to moles times molar mass. So mm is molar mass. So I need to calculate over here the molar mass. To do that, remember, you need the chemical formula, and that's what this is, NaCl. So my molar mass of sodium chloride, make a list of the elements involved. We have Na, which is sodium, Cl, which is chlorine. Number of atoms of each, we're looking at the subscripts. I don't see any. So that means there's just one sodium and one chlorine. Next, we can look up on the periodic table what's their average atomic mass. That's what's going to go in my next slot here. That's what I'm going to multiply the number of atoms by. So sodium is number 11 on the periodic table. and its mass is 22.99. Chlorine is number 17, Cl, and it's 35.45. So, excuse me, tickle my throat. Adding those together, we get 58.44 grams per mole. So this is the molar mass that I'm going to take and plug into my equation. So this guy goes here, and this guy goes there. So we're taking 0.039 moles multiplied by what we just calculated. That's grams per mole. So I'm just showing the unit so you can see that this time, the reason we're multiplying moles times molar mass is so that the moles cancel and our units that are left are grams. So multiplying that out, we get 2.3 grams. In this case of sodium chloride. So you shouldn't have, according to the American Heart Association, more than 2.3 grams of salt per day. So, this is going to be on the Chapter 7 homework quiz that is due on Sunday. And there's also going to be some problems with isotopes and calculating mass number. So make sure that you look at that as well. There might also be just some generalized questions about the periodic table itself. So atomic number, number of protons, that sort of thing. So there's tons of videos to help you learn all that information that are available to you. So use them. Next week we're going to be continuing on with chemistry. We're going to be taking these chemical formulas we've talked about and we're going to identify them as ionic and covalent, and we're also going to learn how to name them. So I already have the videos posted up on that. But we'll be doing examples and working with it in class lecture videos as well.